Hello everyone, my name is Tani Natasha. I'm from a chemical engineering student at Tokyo Institute of Technology, Japan. This time, I would like to review about a paper from a journal called Composite Science and Technology. Why I chose this journal because my research is about composite materials, so that's why I found this journal is very related to my research. And also, this journal have an impact factor of 9.879, so I think it's a very good, and I think we can get more knowledge, and also we can get more insight from this paper. And this paper is talking about the change in mechanical and interfacial properties of glass fiber and carbon fiber reinforced epoxy composite after etching in natrium chloride solution. This paper has published at 2015, so it's about 7 years ago. Yeah, so let's start. Okay, so I would like to introduce about this research background. So basically, it's talking about FRP, or we can call this fiber reinforced plastic. So FRP is a composite that have consists of matrix itself, which is resin, and also reinforcement, which is fiber. These FRP have been used as structural materials like sewage pipes, ships, and wind power plants that have seawater environment atmosphere. And to apply in a seawater environment or severe environment, the high demands on reinforcing of glass fiber or carbon fiber require detailed information about the quality regarding the chemical resistance and strength change, because it will direct us to the corrosion things, because when FRP is like put in the seawater condition or severe environment, uh it can be corrosion it can be corroded after an aging time. So that's why we're also talking about the red corrosion that depends on the temperature, aging time, chemical constitution of the glass, and also chemical composition of aging solutions. That's why it's very important also to discuss about the effect of moisture that in the inside of the fiber itself and inside of the matrix itself, and also between fiber and matrix, because this FRP is consists of matrix and fiber. So that's why very important to know about the moisture inside of it. Yeah, so there are some paper and researcher also before that already overviewing this glass fiber and carbon fiber itself in the seawater conditions. So that's why we can from that paper, from that research, we can conclude that in seawater environment, the interfacial control between fiber and matrix can be very important to transfer high strength of each of the fiber and matrix effectively. So in this research, we have a questions that what will happen if we use glass fiber and carbon fiber composite in the seawater conditions? And the hypothesis of the answer will be like seawater can penetrate to the interface of the fiber or the resin itself. So that's why the area can be weak and will have deteriorated. Therefore, in this research, the tensile strength change of glass and carbon fiber with elapsing days in natrium chloride solution were investigated to know the surface observation, mechanical, and interfacial properties. And the interfacial properties also will be evaluated using non-destructive tests. So in this paper, the author select the material using glass fiber, carbon fiber, and also the resin they use is epoxy with amine hardener. And they use natrium chloride solution as represent of seawater. And also they make the specimen using steel frame like this. So you can imagine how the FRP will be made. And the experimental method, so after we made the specimen and then we put in this, like this is like a schematic of fatigue test. So we put the epoxy resin and also the fibers, and we want to know about the crack itself. So by this optical microscope, we can know the interfacial morphology between the fiber and the epoxy matrix itself. Yeah. So, from after we like elapsing in an NaCl solution, we observe the tensile strength. The figure 3 in the upper one, this is the glass fiber, and in the below, this is the carbon fiber in SAM. So they're using SAM to observe the surface condition. So basically, we can know the carbon fiber is not affected by an NaCl solution. Meanwhile, the glass fiber, we can see that the diameter of the glass fiber is reduced. So carbon fiber is not affected, and it can be also because glass fiber is more susceptible to corrosion by alkaline solution. Meanwhile, carbon fiber can be more stable to chemical corrosion. And we conduct the tensile strength test. So based on this, we can know that tensile strength of glass fiber decrease, whereas the strength of value also decrease. But meanwhile, in the carbon fiber case, the tensile strength of the carbon fiber, it keeps maintains after NaCl solution treatment. And besides tensile strength, we also conduct interfacial properties with elapsing in an NaCl solution after fatigue test. So we can know that this is the neat fiber before elapsing in NaCl, and the red one is after NaCl treatment. So we can know that in case of glass fiber, the rate of change is decreasing, but meanwhile carbon fiber, it does not change. Okay, the strain rate did not change. And also we can see from this figure, this is also to know about the interfacial properties. So we can see that the interface between carbon fiber and glass fiber actually is clean. But the interface between glass fiber and epoxy treating after NaCl solution treatment show a rough pull-out debonding. So in the glass fiber, the effect of decreasing interfacial properties with NaCl solution treatment was larger than the carbon fiber case. Okay, and this is interfacial properties using acoustic emission or non-destructive test. So we can conclude also from the result that the change of acoustic emission energy, amplitude, and even number of carbon fiber was smaller even after an NaCl solution treatment. So the conclusions are, so the tensile strength of glass fiber will decrease as an NaCl solution treatment, but the carbon fiber keep maintained. And the fatigue strength also have a similar result with the tensile strength. And also we can conclude that this NaCl solutions treatment will accelerate the corrosion action and decrease of the diameter of the fiber itself, and also decrease of the mechanical and interfacial properties. So from the results of this paper, I think the result of this paper is good. I agree with the tensile strength and fatigue strength result of the glass fiber that showing decreasing after GOT and association treatment because it makes sense. And also we can know from the literature itself that carbon fiber has more good tensile strength and also flexural strength, and also carbon fiber is have a more resist to corrosions itself compared to the glass fiber. So that's why this result of this paper makes sense. And the comments about this paper, the paper is included in abstract, introductions, material selection, experimental method, result and discussion, also conclusions. The figures are clear. The author also display a schematic of the experiment, so it makes it easy for us as the reader to visualize on our mind about this experiment. But unfortunately, there is no explanation about further work or further research, so that's why it's difficult for us to imagine whether there's a research gap that has not been fulfilled. And takeaway message from this review of papers, so I hope that everyone, especially that know in this materials things or composite material things, can enhance more knowledge about glass fiber and carbon fiber material and mechanical property itself, and also study about using non-destructive tests to evaluate about the interfacial properties of composite material. And the last one also about the corrosion resistance between glass fiber and carbon fiber material through the seawater environment. So yeah, so I hope everyone can enjoy this video and can get more knowledge about this. And I hope also you can know about writing paper, which is the good one and bad one. So you have to make the figure and schematic clear to make a reader can visual their mind. And also don't forget to put the further work or further research so we can know about what should we do in the next step or in the next future. Thank you for listening. Bye-bye.